Hello and welcome back, everyone. In this lecture, I will be talking more about Pluto and why it is not a planet. And so this falls into the overall structure or the overall outcome for our unit is to be able to explain and visualize the structure of our solar system. But we're going to center our story today on Pluto. And this is going to involve you being able to describe the discovery of Pluto, as well as list the different requirements that have been instituted as for the requirements of a planet, and then explain why Pluto does not qualify as a planet under those requirements. And then finally, I'll invite you to critique the definition of a planet and see how it could be made more robust and better, and possibly include Pluto or possibly still leave Pluto out. And so what about Pluto? Well, see, we have our very cartoonish depiction of the solar system. And as you have seen in the prior lectures, this is not what our solar system looks like in any sense of the matter. However, we did not understand really all about what the solar system looked at during the time of Pluto's discovery. Pluto was discovered on February 18th, 1930, after a year of searching by the astronomer named Clive Tombaugh. Clive made this discovery by taking photographs of the night sky and then taking another photograph of the night sky a couple days later. He would then take both photographs, line them up, and flip back and forth between them to try to identify any differences in the photos. What would stay the same between the images were the background stars in the night sky. However, if there was any object moving in our solar system, it would be identified as moving across the two images. And so the before and after images are shown here. So on January 23rd, here is this image, and it includes an object right here. And then on the succeeding 6 days later, that photograph was taken again, and we see that the object has then moved across the scene. Then, after processing the film, Clive was then able to see this movement the next day and identify Pluto. However, astronomers were not content with only discovering Pluto. Back then, they did not know about all of the Kuiper Belt objects that existed in the outer solar system. And there was this apparent emptiness of the outer solar system. And this led astronomers Dave Jewett and his graduate student Jane Liu to begin to investigate what else existed out in the outer solar system past Neptune that could be an object just like Pluto. The astronomers were aided by a new technology that was just being put into the largest telescopes on Earth. So here are the Mauna Kea observatories. These are at the top of Mauna Kea in Hawaii. These are some of the world's best telescopes for viewing the night sky and deep into the dark parts of our solar system. And at this time, in 1988, the first digital cameras were being installed on these telescopes. This technology is called the charged coupled device. This is basically an electronic sensor that detects the presence of light photons and is able to register them about 9 times as better as film was able to. And so they were able to gather 9 times as much light through this new technology than they were with the film technology that had been used ever since Clive Tombaugh was doing the work back in the 1930s. And so with this added technology, they were then able to examine the outer solar system. And what they ended up finding were many Kuiper Belt objects out past Neptune. These objects, again, are existing somewhere between 30 and 100 AU out from the sun. And so these are out past the orbit of Neptune. Some of them actually do cross the orbit of Neptune, including Pluto. They do not form a single disk. They actually form what's kind of like a donut shape, which is called a torus. And so they have very wide or very tilted orbits across the orbital plane of the solar system. Eventually, over 1,000 different Kuiper Belt objects had been discovered to date. And so it is often predicted that there might be over 100,000 Kuiper Belt objects greater than 62 miles wide. And so there are clearly a lot of objects out past Neptune, including Pluto. And so now that we see that Pluto is not alone in this part of our solar system, it then started to beg the question, is Pluto a planet, or what is a planet in general? So we saw this picture in the last lecture of the different Kuiper Belt objects. Here are Pluto. We've seen Pluto, but we have these artistic representations of the different objects. And as you can see, they are very large objects. Some of them are even almost similar in size to Pluto. And in 2006, Pluto was actually demoted to from a planet to being a dwarf planet. What does this mean? There was actually strong public and scientific opposition to this decision from the International Astronomical Union. International Astronomical Union is in charge of defining the objects that exist and can be given names for objects in space. But ultimately, they needed to give a definition to a planet that was consistent and could be applied across the broad spectrum of objects. And so ultimately, they put forth this definition that the planet must be in orbit around the sun. Great. Second, the planet or object must be massive enough to be a sphere by its own gravity. So that means that the object cannot be oblong or potato shaped. Remember the sizes and shapes of all of those asteroids that we looked at. They were very irregular. Ultimately, they did not have enough gravity to smooth out their surface and form a sphere. Finally, the object must have cleared the neighborhood around its orbit. This essentially means that it must dominate the pathway of which it moves through the solar system. All of the planets have removed any gatherings of large objects, any crowded large objects around its orbit. It has had enough mass to pick up those pieces and incorporate into itself. Pluto does not meet this qualification because it exists as one of many Kuiper Belt objects. There are so many objects out there. Pluto or any of those objects do not dominate the gravitational field in that area. So this was the reason why Pluto was demoted from being a planet to a dwarf planet. There are some other facts that don't help Pluto's case for being a planet, but ultimately these were not included in the rationale for the decision. First up, Pluto's orbit crosses the path of Neptune. So here's Pluto's orbit, and as you can see, it crosses the path of Neptune. There are times in its path that it is closer to the sun than Neptune. So that doesn't help. There's no other planets that sort of cross the paths of other planets. And so Pluto was doing this, and that's fairly strange to be considering it a planet. Second, Pluto's orbit is really inclined to the relative inclination of the other planets. All of the other planets sort of orbit around the sun on the same plane. Think of them as billiard balls on a pool table. They're all on the same plane. They're all on the same surface. Pluto is not. Pluto is coming up above the solar system and then dipping down below underneath the solar system in its path around the sun. And so it is very irregular in this sense, and this does not look like any other planets. And finally, Pluto and its moon Charon orbit a center of mass that is outside Pluto's radius. This means that the mass of Pluto and the mass of its largest moon Charon they're so large and so similar to each other that the center of mass for each of these objects is actually outside of Pluto. And so the question is Charon orbiting Pluto, or is Pluto orbiting Charon? I think because Charon makes the full orbit around Pluto, we would say that Charon is the moon, but this center point is outside of Pluto. And again, that is not like any other planet in our solar system. However, there are some problems with the International Astronomical Union definition. It is not as clear-cut. So if we take the different definitions, then it must be in orbit around the sun, fairly straightforward. If we take it that it must be a sphere by its own gravity, also very straightforward. It must have cleared the neighborhood around its orbit. This third one is not very clear. This one is ambiguous and subjective. What does it mean to have cleared the neighborhood around its orbit? What does neighborhood mean? None of these different terms are really well defined. If we consider this, has Jupiter cleared the neighborhood around its orbit? We noticed in the last lecture that it had Trojan asteroids in its orbit, in its neighborhood. It hasn't cleared them. They're there. Does that mean that Pluto, or does that mean that Jupiter's not a planet? Does it mean that the largest planet is not a planet? Ultimately, this highlights that this is not a great definition for a planet, and this was the one that excluded Pluto. And a lot of criticism has been lobbied against this last definition. That ultimately it was subjective and it was used to weed out objects like Pluto. And ultimately, this means that we'll get to this in the next lecture, that there was a time in Earth's history where the Earth was not a planet, that the Earth had not cleared the neighborhood of its orbit. Similar for Neptune, there's objects that cross the paths of Neptune. Does this mean that it has not cleared the neighborhood, it is not a planet? Ultimately, I think that this one creates a lot more problems than it solves, and it has not been debated as enough. And so I wanted to share this with you, that even though Pluto is not considered a planet by the definition, there are still some problems for this in general. Okay, I'll see you in the next lecture.